left-hand side. So we are going to see if you guys remember how to write equations of some lines. And we're also going to talk about some special types of lines in terms of like parallel, perpendicular, horizontal, vertical. So does anybody remember, I'm going to see if I can squeeze it right in here. Does anybody remember how to find the slope of a line? Do you remember the little formula for it? It's your rise over run, but do you remember if you have just points? Yes, very good. Okay, so I'm just going to put M because in almost, except for standard form and all the other formulas for the equation of a line, M stands for your slope. So we call it y2 minus y1, and the little subscript is just to indicate these are two different points, but it's a y-coordinate of one point minus the y-coordinate of the other point, and then over the x-coordinate. And then the x-coordinate and the y-coordinate in the same point should be stacked on top of each other when you do this. And then minus x1 would be the x-coordinate of the other point. Now, does it matter which point you label x1, y1, and x2, y2? It totally doesn't matter. It totally doesn't matter. All right, the same subscript number should be in the same point, though. Like, I usually just, like, the first point I'll call x1, y1. The second point I'll call x2, y2. But it really doesn't matter. As long as the subscripts are the same and the same point, you're good to go. So, let me just set this one up, and then we'll try the next one. So, the y-coordinate in my second point is -9, and I'm going to subtract the y-coordinate in the first point, which is -3. And then on the bottom, I'm going to do the x-coordinate in the second point, which is 7, minus the x-coordinate in the first point, which is 0. On the top there, what does the minus and negative turn into? I knew what you meant. I knew what you meant. This will be -6. Okay, now some people, and if you want to, totally feel free. Some people just know automatically if they get a minus and negative, they'll just write a plus there. That's fine. I'm just writing it out so I can make sure that I'm showing you the formula correctly. But if you end up with minus and negative, it's actually be -9 plus 3 for that one. All right, on the bottom, 7. And then just ask yourself, can that be reduced? No. So there's my answer. Done. All right. Somebody tell me, how would you set up the second set of points there? Like, what over what on your slope formula if you did the slope for the second one? What would you write? Or what did you write on your paper since you're all doing that right now? Liam, tell me what you do.
First I put 3 minus -2. But that's another plus.
Okay.
So I got 5 on the bottom.
Okay, good. I was wondering. Okay, he got that on the bottom. What'd you get on top? Or what'd you put?
-8.
Okay.
-7.
Okay.
And then it equals -8 minus -7.
Okay.
So I got -15 on the top.
Okay.
And then 5 on the bottom. And then I simplified to -3.
Perfect. Perfect. All right. Good deal. Does anybody have any question? Who could try, I'm writing too big, who could try the third example? What'd you get on this one? These last two are a little bit weird. So if I do -3 minus a -3 or -3 plus 3 on the top, those are my two y's. The bottom would be -7 minus 4. What does the top of that become? Okay. Now, is it okay for 0 to be on the top? Yeah, if you actually, here, I'll show you on my calculator. I know we talked about restrictions and everything, so if you have 0 on the top, you can divide 0 by any number, completely legal. It's just going to be 0. So the slope of this line would be 0. We're going to actually do a little bit with that a little bit later today, so I'm going to save that. But you can have 0 as a slope. All right, now this last one also may be a little bit tricky. So if I subtract my y's, I'm going to do 2 minus 6, and then I'm going to do -5 minus the -5. So I get -4 over 0. If you guys, and you guys hopefully know this from us doing our restrictions, but you are not allowed to divide by 0. If you tried to do that on your calculator, forget it. It's an error message. You can't divide something into 0 pieces if it exists. Does anybody know if that's the case, what you would call the slope of that line? Undefined. Did anybody else? There's another, so undefined, or there's another way you could label it. Does anybody know? Okay, just in case, undefined, totally true. The other way sometimes this is referred to is that it has no slope. So both of those are interchangeable. Whichever way you learned it is totally fine. But if you got a 0 on the bottom, and we're gonna talk about this a little bit later today, but it's either called undefined or no slope. All right, now my favorite linear formula. Well, I guess I like mx plus b, but this one's my second favorite, I guess. So point slope formula is going to be what we're going to work on today a little bit to help us write equations of lines. So you need for this, as it says in the title, a point. So I'm going to say I would have x1, y1. That would be a point. And then you would also need a slope, which we're going to use m like it is in mx plus b form. Okay, now point slope. You're going to have y minus y1, which we would fill in the y-coordinate of the point, equals slope, which is m, and then in parentheses x minus x1. This is the point slope formula. I'm just going to grab my highlighter real quick. You would fill in the values for the y-coordinate of the point, you would fill in the slope, and you would fill in the x-coordinate of the point. The x and y that are plain would stay x and y in the formula, and then if we can in the problem, we would use that to simplify. So I'm just going to give you guys a couple examples here real quick. I'm just going to give you 2 points, and we're going to see if you can write the equation of the line between the 2 points. We're going to start with point slope and then ultimately convert it to slope intercept. So first thing you want to do, if you got 2 points, you want to go ahead and find the slope, just like we were doing. So we'll do x1, y1, x2, y2. You don't have to label it or anything, but just in case. So for this one, I would do, let's see, 16 minus a negative 9, or 16 plus 9, over negative 2 minus 3. Fail. What is 16 plus 9? 25? Okay, over, oh good, we have a good slope here. Okay, so negative 5, that's our slope. Now, if you want to use the point slope form, you just pick either one of the points. It completely doesn't matter which one. I'm just going to pick the first one just because I already have that labeled x1, y1. So here's what I'm going to do. I'm going to use this point slope formula. You can see this right above here. It would just be plain y. Okay, now, minus the y-coordinate of the point. Let me do one thing just above here. So this would be minus a negative 9. I'm just going to write y plus 9. All right, equals your slope, which we just said was negative 5, and then x minus the x-coordinate of the point. The x-coordinate of the point that I picked was just 3, so it looks like x minus 3. Now, if you guys are using point slope, this would be the point slope version of this equation. It's super, super quick to get it in slope intercept form. It's 2 steps. You just do a little distributive property with your slope. So I'd have it negative 5x, and negative times a negative is going to make negative 5 times negative 3 plus 15. And then you just do one more tiny step. You're just going to move whatever that y-coordinate you plugged in to the other side. It was plus 9, so I'm going to subtract 9. So my equation, we're going to get negative 5x. And then I just have to subtract 9 from 15. That's going to give me my y-coordinate. So this would be plus 6. And that is a linear equation through those 2 points. Okay. You guys see if you can go through. Can you write, if I just give you 2 points, can you write me the equation of the line? And I know it's a couple steps. So you got to find the slope and then go through, see if you can use that point slope and then simplify to slope intercept form. Distributive property, and then you either have to add or subtract. It just depends on the coordinate. Go through, see if you can do that one on your own, because I want to make sure that's one of the things you absolutely have to know how to do, is how to write the equation of a line between 2 points. And you can pick, when you do the point slope, you can pick either point. It's up to you. leave mine up here, so I'm just going to unfreeze my screen so you can see mine. But it looks like almost all you guys are doing a really, really good job with this. Just be careful. Like when you do the slope, you get -6 over -8. And so the two negatives are going to cancel each other out. So you should get +3/4 as your slope. Now, we're going to talk about some special lines. I'm going to grab a tissue box here too. Okay. Now, what do you guys think about if I say I have two, and I just have a little picture for you so you can see it. So if I have two lines and I tell you that are perpendicular, what does that make you think about? Maybe from geometry or algebra 1, or what do you think about for perpendicular? Perfect. Okay. Form a right angle where they intersect, right? So I've got my little example here in the coordinate plane. So the intersection there would be a right angle. Now, there's a way you could prove they were right angles. Does anybody know how you do that? If you know, maybe if you know the equation of the line, or how would I know that two lines are perpendicular?
One slope's going to have a difference.
Exactly. So the slopes are, however you want to call it. If you want to say negative reciprocal, or sometimes I hear that called opposite reciprocal, it just means one's positive and one's negative. So slopes are, am I spelling that right? Yes, opposite reciprocals. Okay, so what do I mean by opposite reciprocals? Actually, if you guys want to, maybe we'll just pick it out on the graph here. Let me see if this has a decent slope. Okay, so this equation, I'm going up 1 over 2. So one of the slopes is 1/2. And I'm just trying to grab 2 points that go right through a corner. And I always go from left to right. So if I have to go down and right, then I know this one's going down 2 over 1. So then negative 2 over 1. Those are opposite reciprocals. So opposite just means, or negative reciprocals, if you want to think about it like that. One's positive and one's negative. That creates the two lines going in different directions to get the 90-degree angle. And then the reciprocal part makes that 90-degree angle as well. But they have to go two different directions. So one's positive, one's negative. All right. What about parallel lines if you have them on a graph? What'd you say? Yes. Okay. Same. They don't form anything. They don't, right, parallel lines don't intersect. They don't ever touch each other. Okay, so they have the same slope. Anything else? Like they have the same slope. Yes? Yes, yes, that's what I wanted you to say. All right, different y-intercept. So technically, maybe don't draw this on your paper, but like I could graph like a line right on top of this and they would have the same slope, but they'd also have the same y-intercept, so they would not be parallel to each other. So there's just like a little side thing. They have the same slope, but they have to have a different y-intercept to be parallel. Okay, now I'm going to have you guys write some more equations of lines, and we're going to do this in two different formats. So I'm going to do it from slope-intercept form. I'm going to do it from standard form. And we're going to use that point slope to help us do this. All right, so it says write the equation of a line through the point. So they're going to give me a point that is parallel to this given line, which says y equals 2/5 x minus 3. Okay, so all I need is I'm just going to put a little symbol like that for parallel. You guys okay with that? What would a line that's parallel to this have as its slope? What would a 2 over 5? When you're doing parallel, you're literally just going to copy the slope. So whatever it tells you, this one it's easy to see because it's in slope-intercept form, 2/5. You just copy that. Now, do not use this line for anything else. Like there's always somebody that goes and tries to like plug the points into that or something. You're just using it for its slope, and then don't use it for anything else. Now, I'm going to use that point slope formula. So I'm going to do y minus the y-coordinate of the point equals, this is going to be our slope, which is 2/5 times x minus the x-coordinate of the point. All right, so I really have here y plus 4. Now, this is not the nicest number. I'm going to get 2/5 x, and then let me see what that is. 2/5 times 3 is going to be negative, what? No, sorry, 6. I already got the negative taken care of. 6/5. And what I'm going to do is I'm going to subtract the 4 from that. And I'm going to show you my favorite button on the calculator. So we can have, because I use this all the time. Okay, so if you guys have a graphing calculator, I'm doing negative 6/5, right? Now, whenever you do a negative, make sure you use the negative key under the 3. Don't use the subtraction sign. It doesn't like that. So I'm going to do negative 6 divided by 5, and I'm going to subtract 4. And I'm going to hit enter, right? And it's going to give me a decimal. And I know you probably could figure this out, but I want to show this to you real quick. If you get a decimal, and Math Excel always seems to want a fraction. This is my favorite 2 things. Just hit the math button, and then you're going to hit enter twice. And it will convert any decimal you have into a fraction for you in lowest terms. So this would be minus, 26/5, just so we have an exact answer. It would be kind of tricky to graph that on a graph. We're just writing the equation here. But again, all I just did my negative 6/5, I subtracted 4, and then my favorite combinations of buttons, if you want to convert any decimal to a fraction, you're going to hit math, and then you're going to hit the enter button 2 times. It'll give you fraction, reduced, and everything. Is anybody having a question? Okay. Now, this one is a little trickier. We're going to do kind of the same thing, but this is not giving you the equation in slope-intercept form. This is standard form. So this is a little bit trickier because I can't just look at that and see the slope. So what I would maybe do, how would you guys find the slope of that line? Like, what would you maybe do so you could tell what the slope was? Yeah, exactly. I would just move this guy to the other side. So I get 2y, 6x. I'm just going to slide the 8 to the side just a little bit, and then divide by 2. So it ends up 6/2 is 3. You don't really completely need to know the equation of the line. You just really need to know the slope, and then you're going to copy that slope. So if you want to transform it into slope-intercept form, again, it doesn't really matter what the y-intercept is. You just need the slope. Then, if you're going to be parallel, my parallel slope, we're just going to copy that 3/4. And then I would repeat the same process. So just real quick, do y minus the y coordinate of the point. So y minus 2, 3/4, and then x minus the x coordinate of the point. Man, I picked some bad. Oh, what am I doing here? 3. I don't know why I just wrote 3/4. Okay, I saw 3x plus 4 and I wrote 3/4. All right, sorry. 3. So this is actually nice. We just get y minus 2, little distributive property, 3x minus 21, and then all you got to do to get slope-intercept form, just add your 2. So y equals 3x minus 19. Anybody having a question? Okay, let's do perpendicular. And then we're going to do, real quick at the bottom, we're going to do horizontal and vertical lines. All right, so perpendicular, if I'm going to write the equation of a line through a point, they're going to give me the point negative 5, 6, perpendicular to y equals 3/2x minus 5. What would the slope of a line perpendicular to that line be? Negative 2/3. So you just take the fraction. So original equation there is positive. So the slope of a perpendicular line has to be negative. And then you just take the fraction, flip it over. Okay, now remember, don't use that for anything else. You're just using it for its slope. Don't plug the numbers in there. Someone always does that. You're going to try and write a completely separate thing. I would just use that point slope. So I'm just going to do y minus the y coordinate of the point, which is 6, equals our slope, which is negative 2/3. And then x minus the x coordinate of the point. Now this is going to end up, I'll just write it above here, it's going to be x minus a negative 5, so I'm just going to write x plus 5 when I do that. Little distributive property, y minus 6, negative 2/3 x. Okay, if you multiply a fraction by a plain number like that, it's the numerator times the number, so negative 2 times 5 would be negative 10, and then over the denominator. And again, I'm just going to use my lovely resource of my calculator because that's not a nice number. So I've got 2/3 x. I'm just going to grab my calculator here. Okay, I just do negative 10/3. Just put parentheses around it. I'm going to add 6. And I know you guys could convert that, but I'm just lazy, so I'm going to use the calculator. So just hit math. It's the it's the fourth button down on that left side. Just math, enter, enter, and it'll give you fraction, all reduced and everything. So this will be 8/3. I use that button constantly. Is anybody having a question? Okay, now this one's a little extra. So if it's in standard form, it's not super easy to see the slope. So what I would tell you to do, just get y by itself real quick. So I'm going to subtract the term with the x and keep the negative in front of the 2y. That's important. And when I do the slope here, or slope-intercept form, I just write the term with the x right after the equal sign. And then if there's another number there, like there's a -1, just slide that down. That'll be more looking like slope-intercept form. Divide everybody by -2. Honestly, it doesn't matter what the y-intercept is here. I'm really just interested in figuring out what the slope is. So the slope here is 2. What would the slope of a line perpendicular to that be? It's just a plain 2. Yes, -1/2. If your slope ends up being a plain number, like I got 2 here, if you want to make an easy way to make it a reciprocal, you can write any plain number over 1, and then that might give you a little bit easier time of flipping it over. So it's +2, so my slope has to be negative because they have to be opposites. And then if I flip that over, I would get a 1/2. All right, now we're just going to plug this in. So I'm going to do it'd be y minus a -3. So I'm just going to write y plus 3. And then -1/2 x minus 8. Then you got 2 steps. We're just going to do a little distributive property. So you got -1/2 x plus 4, because it's minus a negative. And then all I have to do to get y alone is subtract the 3. So you should get -1/2 x plus 1. And I know these have to be perpendicular because their slopes are opposite reciprocals. Could perpendicular lines have the same y-intercept? They can't. The only thing that's required for perpendicular is they have opposite reciprocal slopes. It is possible they'd have the same y-intercept. That's only an issue if you have parallel lines. All right, now my favorite. So if any of you know Mrs. Bay, she was my math teacher when I was in Honors Algebra 2 a million years ago. And she taught me this trick, and I have used it now for more years than you've been alive. But anyway, this always trips people up. So horizontal lines, flat like the horizon, and vertical lines, straight up and down. Now, the thing that trips people up, they think about the x and y axis, right? And your x-axis is a horizontal line. But if you have a horizontal line, they have an equation, and it's just y equals some number. And that trips everybody up because they're thinking x-axis, they think it should be x. All right, so she taught me this little memory trick. Use it if you want. And she called it horizontal. So anytime you have a horizontal line, I literally say this to myself all the time still. Horizontal, it's a y equals a number. Let me come down and show you why. So I usually tell people, like, this says graph y equals 3. Tell me a point, like where would a point be where the y coordinate would be 3? Like, see if you could just come down to the graph. Think of a like where is a y coordinate equal to 3? Anywhere. Okay, perhaps like 0, 3 maybe, right? Like a lot of people will start there. And then I'll say, okay, show me another coordinate where the y is 3. And then people will tell me all kinds of random stuff, but I want you to think about this. The y coordinate is 3 here, right? That's the point 0, 3. This is 1, 3, 2, 3, 3, 3, 4, 3. All the y coordinates are 3. The x coordinates change as you go left and right, but all the y coordinates are the same. So that's the only requirement for that line right there. And I don't know if you guys remember this. We talked about this on the front. The slope of this line, like if I just think about this, if I did rise over run, if you grab 2 points, you would be going up 0 over 1. And so the slope here is 0. And if this helps anybody in any way, I used to do it like this. Just take the line and turn it into a z. The slope is 0 for any horizontal line. So you just want to find that y value. Find that y value, like the next one says y equals -2. Just find -2, and we're going to go just horizontal line. All those y coordinates are -2. The x coordinates change as you go left and right, but all those y coordinates are -2. And I'm just going to add this to this graph just so you guys know. What would the equation of the x-axis be? Anybody know? X-axis is a horizontal line too. Does anybody know what the equation would be? Y equals... What are all the y coordinates across the x-axis? 0. That always trips people up, but the actual equation of the of the x-axis is y equals 0. So it's a horizontal line there. All right, now vertical lines, similar. Again, people kind of mess it up because they think vertical, they think the y-axis, but any vertical line is actually x by itself equals some number. And to help remember this, I call this vertexal. And I just remember, like, I literally say that to myself. Any vertical line is x equals a number. So like vertexal, I say that to myself. So if I'm graphing a vertical line, I know find an x value. So example, here's x is 2, 0, right? Here's 2, 1, 2, 2, 2, 3, 2, 4, forms a vertical line. And I know it trips people up because it's parallel to the y-axis, but this is actually x equals 2. All the x coordinates are the same. Now, if you want to think about slope here, if I were to grab 2 points and do my rise over run, you are going up 1, but then you don't move left or right, 0. So remember we were talking about out in front, that's not legal. So this is either no slope or undefined. So I used to turn this into a no slope like that with an n. So no slope, or if you prefer undefined, both of those are correct. All right, and I'm going to do one more. X is -4. Just find -4. You're going to draw a nice vertexal line through -4. That would be my graph. All the x coordinates along that line have the point -4. The y coordinates change as you go up and down. And then just to keep it consistent, if you guys actually look at the y-axis equation is x equals 0 because the y coordinates change as you go up and down, but all the x coordinates are the same. Now, last thing I'm going to do, and you don't really have to have a graph for this, but I put a graph on here because I think it makes it a little bit easier to do. This says, write the equation of a line parallel to y equals 3. So let me just draw a nice horizontal line at 3. You don't have to go through the information that we did like with point slope or anything to do this. So I want to be parallel to this line, and I want to go through the point. Let me plot the point, -2, -1. Can anybody tell me an equation that would go through that point that would be parallel to y equals 3? You're close. It's not -2. It's just y equals the y coordinate of the point. Yes, 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 yes. Okay, all these y's. It goes through the -2 as the x coordinate for that point. But I want the y coordinate. Parallel lines would both be like a y equals. Or if you had x equals a number and you need a parallel line, it would be x equals. But if you're parallel to this, it's just y equals the y coordinate of the point. All right, now, this one's trickier. This one's perpendicular. So I'm going to take the y equals -2. So I'm just going to sketch that. There's y equals -2. Horizontal line. All those y coordinates are the same. And I want to be perpendicular to this line through the point. Let's see, where's 4, -3? Okay, so if I'm a horizontal line, a perpendicular line would have to be what kind of a line if I'm horizontal? I'm not doing like opposite reciprocal slopes here because it doesn't work that way with horizontal and vertical lines. So if I'm horizontal, my slope is 0. 0 does not have an opposite reciprocal, so I got to think about this for a second. If I'm a horizontal line, what type of slope, or what type of line would be perpendicular to a horizontal line? Vertical, yeah, okay. So vertexal. All right, so all I got to do these guys are going to intersect at a 90-degree angle, just like your x and y axis, right? It doesn't work to do the opposite reciprocal for these. So all I'm going to do here, straight up and down, and it goes through that point. So this is just going to be x equals, and it should just be the x coordinate of the point that they give you. So x equals 4 goes through that point, but then is perpendicular. Any horizontal line and vertical line are going to be perpendicular to each other. Doesn't kind of work with that opposite reciprocal slope like we were talking about. Is anybody having a question?